Yeah, hello everyone. It's a pleasure to be here. So yeah, as has been said, I'm actually a scientist. I work in hydrology and climatology. I run climate models, but I use Python for my research, for scripting, and for data analysis. And I'm talking here about a Python class that I wrote that sort of simplifies a lot of the repetitive tasks in my daily work. And this seems to be a bit of a sciencey session here, so maybe just a show of hands because I'm curious. Who here has a science background? Okay, quite a few people. Nice. Yeah, so I used to go to U of T. Now I work at this company at Quanti. It's a hydrologic consulting company. But never mind. So that's basically outline what I'm talking about. Just a brief introduction. Then I mainly talk about this ensemble class that I'm using, and a bit about argument expansion as well. So this is mainly just like a class to save you some work, and I hope someone will find it useful. So the basic problem is that science is inherently repetitive. So we do a lot of experiments that have to be repeated over and over again, partly because there's inherent variability or error, so that we need to get good statistics, partly because we have to test a large range of different parameter values for exploration or for just optimization in engineering. And so people have developed tools to automate this process, and I'm going to talk about one of those tools that I've used. So just to show you a few pictures. This is from a climate model here with a regional model here set inside. This was what I mainly do, and this is a hydrologic model. So I sort of work at the interface of these, trying to combine climate forecasts with hydrological modeling to study the impact of climate change on water resources. And we run these models on high-performance computing facilities, for example, on SciNet here at U of T. And the climate models are really the most expensive ones. So to run a forecast with a decent ensemble meaning a number of different simulations that are all sort of similar, but with slightly perturbed parameters. It takes, in total, something like 500 to 1,000 core years for a projection. Whereas the hydrologic models are much, much cheaper to run, but then you can test a lot more parameters. So here you have really large ensembles with several hundred at times. And so to manage all of this, you need to summarize it somehow. And in numerical or computational sciences, we can script a lot of this, right? So if you're running a large ensemble, we can just do a loop to launch all of these simulations. And you can do this in Bash or in Python. And Python is really very useful for this kind of thing, because Python not only has loops, but also list comprehension, which makes this syntactically very compact. But I still find this is very tedious to write if you have to write a ton of those different operations. So I want to improve a little bit on that. So there's a lot of boilerplate code involved, even in Python. So the ensemble class I'm going to introduce, basically the design criteria, or what I want to be able to do is to just initiate the ensemble, then call operations with their arguments just on the ensemble, and it should just apply it automatically to everything. Similar to a NumPy array in some way, that any operation you call on the NumPy array is applied to all the elements, essentially. Also want to be able to access the members in different ways. Right? So essentially emulate some kind of container type and redirect method calls to the members. That's sort of the main design criteria. So the container type is fairly easy to implement. We just have to have these methods, lengths, contains, iter, and so forth. So we can sort of define a get item here and access items like either from a list. So there's a list with all the members of the ensemble. This list can be as long as you want. Or we can use this we can give it a string and then access like a dictionary, depending on how we implement it. And for iteration, we would just iterate over the list. Right? This is a fairly straightforward implementation. One important thing is whenever we call a method on the ensemble, we want it to return a new ensemble with the results. Otherwise, it's not that useful. The more complicated part of this implementation is how to redirect the method calls or attribute calls. I do this with a get attribute. And that basically, if you call an attribute or a function on a class that is not a class or instant method, then you have to then it goes into the get attribute, and then you can implement how this will be resolved. And in this case, it will be resolved by taking the attribute from the ensemble members, checking if it is a method or an attribute. If it's an attribute, it's very easy. You just get the attribute, collect it into a list, and then return it to a new ensemble. That's very trivial. If it is a callable function, it's more difficult, because then we have to deal with the arguments of that function. And for that, we need a wrapper class. And this needs to be implemented separately. It's sort of a helper class. This wrapper class, when it's instantiated, it takes the ensemble members or the ensemble itself and whatever attribute is being called. And then Python, so the get attribute function will return this ensemble wrapper, and then Python will call the call function on that with the arguments that you had passed on it or to it. And this is implemented here, and then here it's basically just implementing a loop over all the ensemble members where it calls the function with the right attributes and appends it to a new ensemble. But this all happens under the hood. You don't really see this. And this part here can also be parallelized very easily. That's a lot more extra code if you parallelize it, but then you have this implemented, and it just all happens all the time implicitly, and you don't have to think very much about it. And this type of parallelization is very easy to do, because it can just distribute the tasks. Yeah? OK. Now, briefly for arguments. Now, if we have a list of different arguments for the different ensemble members, which often happens, then, and we do something like this, where we have a list comprehension again, then it's not very useful, right? Then we are basically where we started. So we want to have something where we can just pass it the list of arguments, and then just tell it which list to expand, and just handle this internally. And this can be implemented as well. If this is just one list or several lists that are expanded in parallel, what I would call an inner product, you can just do this with zip internally in this structure here. You can just have a zip here. So that's pretty easy. The more complicated case is where you have several arguments and lists of different parameter values for all of these arguments, but you want to do all different combinations. And this is usually what happens in my research, that I have several parameters with different possible values, and I have to test all combinations. And this gets really large very quickly. And normally in Python, you would have a bunch of nested for loops where you construct this argument list. And this is the part that gets really tedious. And especially if you want to change something, changing around these lists and these nested for loops is very error prone. And here you can implement something that I call the outer product expansion, that you pass it like this, and you just tell it that there's multiple lists to expand. And the way this is implemented is with a recursion that it essentially it takes one list after the other, and sort of it essentially makes an outer product of all different components, and creates a long list for each one list for each ensemble member with all possible different components. And yeah, this is implemented recursively. I won't go through the details here now. And you can also implement this as a decorator, and then you can use it on all kinds of other things where you have multiple arguments that you want to test. You can just add this as a decorator to a function, and then you can sort of use this kind of syntax. So I find this extremely useful, and that's sort of the main outline of this class. So the ensemble class and the argument expansion together works really well to reduce a lot of boilerplate code and streamlines a lot of my work. I would like to propose this as a sprint, if anyone is interested. And for that, I would say one thing is to just pull all this out into a separate module so that anyone can use it, make it more generic. And then we could also add array-like item assignment support. That would be something really cool to have. And that's it. Yeah, thank you for your attention.